Before we can jump right into question 2, I would just love to reflect on question 1 and say that question 1 was really a warm-up. I always say that if you master question 1, you will be able to master the whole of the question paper. And not only that, I think you will be able to also master question 2 because you use a lot of algebra in mathematics. Now, when we go to question 2, the question that will definitely get there would be a question that focuses on sequency and series. Question 2 is most likely going to be a quadratic sequence because we have 3 types of sequences that we study. Now, this question reads as follows. We are told here that the quadratic sequence defined by the general term given by this formula here has the following properties. They say T9 minus T8 is equal to a 30, T21 minus T20 is equal to a 6. Now, if we write all this down here, just for us to be able to break this question down, we have a quadratic sequence. We are told that it's given by a n squared plus bn plus 1. And there's 2 distinct properties that we have here. We can see that the difference between term 8 and term 9 is equals to a 30. And the difference between term 21 minus term 20 is indeed equals to a 6. And you can see that this really gives us the properties of a quadratic sequence, in that you have the quadratic form here, ax squared plus bx plus c, except that we use here an n because we're looking at the number of terms instead of the variable x. Now, going to the first question, they say to us that 2.1 show that the nth term of the sequence is given by that formula. So if you look at our formula here, we actually don't know the value of a and the value of b. So here we want just to prove that a is -1 and b is equals to 47. You know, if you get a question like this, I will tell you now that it is the easiest question you could ever get in quadratic sequences, because it directly speaks to you in terms of what you should do. Well, I'm going to use these 2 properties of this sequence to actually build equations that will help me to find the value of a and b. So under 2.1, I'm going to say that if I take what I'm given, T9 minus T8, and I say is equals to a 30, you know, the difference between 2 successive terms. Now, what I'm going to do is that I'm going to use the formula that I have here and put a 9 here and put a 9 there, and subtract that to the same formula, but I put an 8 here and an 8 there, so that I do a first set of my equation. So now here, this means I'm going to have a 9 squared plus b times 9 plus 1. So what I've done here is that I've taken this and substituted the 9 here on at the end. But remember, we are subtracting this term 8. I'm going to put a bracket here because I have a trinomial. I'll build a trinomial inside the brackets there. I'm going to have an a again here, but now we have an 8. So this will actually develop into a square bracket because I have other brackets in there. So I have an 8 squared. I'm going to have a b times an 8, and I'm going to have a plus 1. I'm going to close the square bracket, and we're saying this will give us a 30. So what I've done now is that I've taken this and put an 8 in terms of n, because we know that this is the 8th term. So our n is 8 there. But we're saying that if you take the difference between these 2 terms, they must give you 30. That's what we are given here on the original statement. All that's left here is really to simplify this so that I can have a very nice simplified equation. We know that 9 squared will be 81, so this means I'm going to have 81a And here I'm simply going to have a 9b plus 1. And we know that 8 squared is a 64. So I'm going to have a 64a. But remember, I'm multiplying this here by the negative. So this will give me a negative 64a. And I'm going to have here 8b. But again, the negative will multiply here so that I have a negative 8b. And I just have a negative 1 because the negative will multiply that 1 there. Then I have a negative 1. And this should be equals to a 13. They are like terms that I can group together here. If you look at the a and the a here, I'm having 81a minus 64a. That should give me a 17a. So these two here, they give me 17a. And I also have 9b minus 8b. That will simply be a b. A positive b there because, you know, the number that has a bigger sign is a 9, it is an 8. And you would notice that the 1 and the negative 1 will cancel out to be a 0. And this will be equals to a 30. Now you'll notice that here I have the two variables that I'm looking for, a and b, that I'm looking for. So usually when you have an equation that has two unknowns, it means we are going to solve that equation simultaneously. So I can name this to be equation 1. I do the same really with the second property that I'm given for this equation, for this sequencing. So that means I'm going to say from the fact that we know that term 21 minus term 20 is equals to a 6. This would mean I would use the original equation and put a 6 here, a 21 here, and subtract that to putting a 20 here. So when we put a 21, we're actually going to have an a 21 squared plus b 21 plus a 1, but we're subtracting here. We're saying this is going to subtract. I'm going to put square brackets here, the a, but now our n is 20 squared plus b times a 20, and we have plus 21. And this we're saying is going to be equals to a 6. I hope we are following each other and we can see what we are doing. I'm doing the same operation that I did with the first one, except in this case I'm using a 20 and a 21. I'm substituting them there. Now here, from here, this question becomes very, 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 very boring because we are going to do the arithmetics that we are used to from grade 7, where we just going to square, group terms that are the same and all that. Very boring stuff. So now if we look at this, we are going to then say 21 squared should give us 141a. So this is 141 and we multiply by a is 141a. And here I'm simply having plus 21b, and we have the 1 there. 20 squared is simply 400. So this is 400a, but if I multiply by the negative here, it's going to be minus 400a. And here I'm going to also have minus 20b because, you know, you multiply by the negative outside of the bracket, and we're going to have negative 1 as well. And this should be equals to a 6. You could quickly see here that the 1 and the 1 would cancel. Already we saw that because they add up to 0. And if you say here 441 minus 400, these are like terms, right? We should get 41a. So here we're going to have 41a. And if you say 21b minus a 20, that should give me a b. And this is indeed equals to 2. Now we have a very much simplified equation, which I'm going to call equation 2. Now, when you look at these two equations, we have to then simplify them simultaneously. There are many ways of doing simultaneous equations. You can make a subject of the formula or b subject of the formula and find the answer. But there's something unique that I see here. I'm going to use elimination method because I can see that the b and the b here would simply just cancel each other out. So what I'm going to do is that I'm going to say equation 2 minus equation 1. So I'm going to subtract equation 1 from equation 2. So that means now I'm going to say that 41 minus 17, the 41a here minus the 17a here, and that gives me a 24a. And I'm going to say the b minus the b, that gives me a 0, it goes out. And I'm then now going to say a 6 minus 30, and that gives me a negative 24. And therefore, this would mean that my a is equals to a negative 1. Remember, what I'm doing here is that I'm dividing by 24 on the left-hand side and on the right-hand side. The a and the 24 and the 24 would cancel each other out, so that I'm left with really an a. And this side, they just give me negative 1, because negative 24 divided by 24 should give us a negative 21. Now, at this stage, I'll then say we can use any of these two equations, 1 or 2, to then find the value of b, because we know a. Is either I'm going to put the a here or here to find the value of b. I will just choose to work with equation 1. It doesn't matter really which one you work with. So I'll say substitute the value of a is equals to negative 1 into equation 1. So that now on equation 1 we have a 17a. So we have 17 a. I'm not going to write the a here now because I know that the a is negative 1. I'm going to say 17 negative 1. So I'm saying 17 negative 1. I'm here 17 negative 1 because we know that our a is negative 1. And then we're going to say plus a b is equals to a 30. This was equals to a 30, if you would remember that equation. Now at this stage, we will then say we have here negative 17, because 17 times negative 1 would be simply negative 17 is equals to a 30. Now when I take this negative 17 to this side, I'm really going to have 30 plus 17. And if you say 30 plus 17, you should get 47 there. So my answer for b, therefore b would be equals to a 47. Now this looks like something that I've seen on my equation. I can see that my b is 47 and my a is negative 1. So I'm going to really take this equation that we started with and put the value of a, which is negative 1 and 47, and we would have proved this equation. So I'll say therefore the general formula, or the nth term, would be given by negative 1 n squared plus 47, which is my b, n plus 1. And this is actually proved. Hence proved. Now let's see how this will give us the marks. So it was out of 4 marks to do this question. It means you need to spend around about 4 minutes. You'll get a mark for constructing equation 1, and then get a mark again for constructing equation 2. Then they'll give you a mark for finding a and finding the value of b. You don't necessarily get a mark for writing the general formula, because already we are given the general formula. We know what we're supposed to prove. Now we then jump to question 2.2 that says that calculate the values of the third and the 21st terms. Now this should be a really boring question, because what we want here is to actually find the third term and also the 21st term. So that means we simply use this formula here by substituting the value of n to be 3 and the value of n to be 21 to find those terms. So if we say T3, term 3, I'm going to say I'm having a negative 3 squared plus 47 times a 3 plus 1. And we can quickly pull a calculator to actually do that, to say we're having a 3 squared plus 47 times 3 plus a 1. And that gives us here 133 as the third term. Then if we go to the 21st term, really, I'm going to have a negative 21 squared plus 47, 21 plus 1. All I do again is really come to my calculator and put 21 now, because I'm looking at the 21st term, and that gives me a number of 547. So the 21st term should be 547. And this really is out of 2 marks, meaning they give you a mark for finding each term there, the final answer there. This is very, very simple to do. There's no, these are free marks. You should be collecting the marks. And just to give you also a tip, it is possible that maybe this question can be difficult for you. You are not able to come to this answer. But you don't have to give up on this question, because the fact that they've given us this answer here, it means you can continue here by using this to answer this question here, and the other questions that are coming below that, you can be able to answer those. So it means you can lose a mark here but be able to answer the other questions. Now when we go further to question 2.3, they say to us, hence or otherwise, write the series. So they've given us a series here which is defined by all these numbers here. Write down this series in a sigma notation. Very, very important. A very unusual question as well, I must admit here, where we are requested to write a sigma notation in a quadratic sequence. Very interesting. But let us break it down. The first thing that you have to notice here is that when they use the word hence, we spoke about this in the previous question where we did question 1. Hence would mean that you use the information that you've calculated in the previous questions to answer this question. So we have to go back here, and take what we have here to answer this question. It gives you that. But here we have an option of otherwise. Otherwise would mean that you can use a new method. Otherwise would mean you can use any other new method that you can think of. But I'll advise you that sometimes it's easier to stick with hence, meaning to use what we have from the top, because usually it will be a shortcut. So, the 2 marks there will help you. But an otherwise method usually would be a long method where you start to do new things, and it could be long, it could be outside of 2 marks. It could be something that takes you too long. But without wasting time, I think now we have to then pay attention on the series that we are given. So this is a series because we are adding terms here. We are adding terms, so it becomes a series. Now, this is rather a very unique series if you look at it, because, we have fractions, and in our fractions, the numerators, they are always the same. We get a number 2. Very important to observe that. But here we have numbers that vary. Now, when you look at these numbers, and you look at the previous question, as I said, when they use the word hence, they tell us that we must go back to the previous question and see if we can continue taking that information to answer this question. When you look at term 3, it came out actually to be 133. And when you look at the first term in this series here, is a 2 over the 133. And also when you look at the last term in this series here, we have a 547, and here on this previous question it was actually this 21st question, 147. So it seems to me that at the bottom here in my denominator here, I have the quadratic sequence that we were dealing with, and my numerator is just a constant number 2. Being able to see that makes this question to become really easy to answer. Now, before we can continue, I just want to confirm my theory to say, is this the quadratic sequence that we have at the top? So I'll say that we know that if we put 3 here, on n, if we put 3 on n here, we get 133. So if I put a 4, if I go to T4 here, I put a 4 here, I should get the 173. Then if I put a 5 here, I should get the 121. And if I put here the 6, I should get 147. And obviously we know this will continue just like that here. There are other terms in between until we get to T21, which we have done in the previous question to be 547 as it appears here. To do a sigma notation, we all know that it has the structure such that we have this sigma notation, and we are starting from a number I to some number j there, and here we have to put the nth term or the ith term, the general term of that series that we're working with, meaning The I here would be where we start, and we'll build those terms by putting the next term following the one that we start with. So now what I'm going to do now is that I'm saying this is the lower bound. This is where we start our terms, this is where we end our terms. Now it means this sigma notation will develop into I is equals to a 3. Why a 3? Because if you look at our previous term here, when we put 3, we get the 133. So if we put a 3 here, we get the 133, which is what is here. So that means I'm going to start at I is equals to 3. And we are going to really end at I is equals to 21, because the last term here, the 547, it occurs at T21. So it means we will end our terms at 21. But now how do we construct this? Well, we know that in this sequence, we always have a 2 as the numerator. It doesn't change. We always get a 2 here, a 2 here, a 2 there, a 2 there. But here at the bottom, we actually have this quadratic sequence here. The only thing that I'm going to do is that I'm going to change the n to the I, because remember, with a sigma notation, we don't have the n here, we have the I. N is not the number of terms, it's where we start and we build on from there, putting in all the other terms. So here I'm going to really have negative I squared plus 47I plus a 1. And indeed, this should give you or reproduce this very series. You can go test it by putting different values of I, starting with a 3 here. You will find that you'll get this term. If you then go to a 4, because after 3 comes a 4, you will then get this term. And you can continue doing that by going to term 5, term 6, and 7. So in our sigma notation, the first term would be the one that starts at 3 and it will end at 21. Now this question really is only for 2 marks, because there isn't much that we're doing here. They will give you a mark for writing the correct nth term there, or the general formula for this series, and also give you a mark for the correct bounds, lower and upper bounds, your limits, that if you get them correctly. So that will be where the 2 marks will come from. Now going to the next question, we are required here to then answer a question 2.4 that says, between which 2 successive terms will the sequence have the maximum value? Now, if you look at this question, we are being asked about the sequence. In other words, we have to go back to this sequence that we're dealing with. So this question does not relate to 2.3, because 2.3 speaks about a series. So it's very important to know the difference between a series and a sequence. So here we go back to the original sequence and we're looking for the maximum value. So we're looking for 2 terms that will put the maximum value in between them. Now I want to look at this from a different perspective. So if we look at this question is 2.4. Now if you look at our general formula of the sequence is Tn is equals to negative n squared plus 47 n plus 1. Right, now I'm going to view this as a graph. So if you look at this, it's a sad parabola, it's a sad graph, because we're having the value of a here to be negative. And obviously a graph usually would be in a form of a Cartesian plane here. I'm just drawing it randomly, and my Cartesian plane, usually this is the x-axis and this is the y-axis. You have to notice that the x-axis here represents the number of terms. So here it means this part of the sequence here is the number of terms. If we look at these values that are here, is the number of terms. And we know that the number of terms here must be an element of natural numbers. They must be the counting numbers, your 1, 2, 3, 4, and so on. Because when we count terms, we count them using natural numbers. So we have to only look at 1, 2, 3, and so on. You can't be looking at the number of terms by using 0.5, 5.2. but in terms of it looking at it as a function, it's all the values here. So very important to look at that. The other thing is that, for example, if I look at, let's say, term 1, if I get a number here, this number here would be a T1. In other words, whatever number that I get for term 1, it will come out as the first term here. So my y values actually represents the number of terms. I can say here, I'm actually having Tn. It represents any term in the sequence. Now, to answer this question, you have to understand that the maximum value, meaning if I put the value here of n, will occur at the turning point. The maximum value will occur at the turning point because all the other values in this function are actually small on this number. And now this would then give me here Tn, the maximum term, right? So these are the maximum value and the maximum term here. So what we are requested to find in this question is to really find the terms that are between this maximum. So if here we have the n values here, what terms will we get here? Which terms will we get here? And also which term will we get here? That's what we are looking for. What terms will we get that put the maximum value in between? Because this is a turning point, really, I can use the turning point formula, of a quadratic function, where I'm going to then change it. My turning point formula is given by x is equals to negative b over 2a. So in this case, I will change it to an n because we said our x is the n, is the number of terms. So I will say n, I'm looking at n where it is a maximum, is going to be a negative b over 2a. Now when we look at our formula, we can see that the b would be a 47. So this means here I'm going to have a negative 47 divided by 2 times a is a negative 1. If you look at our a here is a negative 1. And by doing so, I then, I'm going to get this number here that occurs at the maximum point. I'm going to get the number of terms at the maximum point, and later on I can be able to answer my question. Now, what's going to happen here is that I think I can press this on a calculator where I'm going to have negative 47 over 2 times negative 1. So this says I'm going to have, so I'm going to have here not a negative, it's going to be positive here, positive 47 over 2, and this can be written as 23.1 over 2, because this goes 23 times remainder of 1, and we put these two as it is there. You can leave your answer either here or here, it doesn't matter. Now when you look at this is where we're going to have the maximum term, but also you can see that this number here is actually not element of real numbers, but then we want we want the terms that put this number in between. This is probably why they didn't ask you to find the maximum term, because the maximum term here occurs when n is actually an irrational number. But nonetheless, if this is 23 and a half, so it means here I'm having a 23 and a half. It means the next term that will come after this will be a 24, and the term before that will be a 23. So my answer to this question would be then that, therefore, the sequence will have maximum value between term 23 and term 24. That's your answer. Between term 23 and 24, you will get your maximum value. In between these two terms, you will get your maximum value. It is as simple as that. Look, I want to share with you another method of doing this, which is a very interesting method using differential calculus, where we're going to take our Tn is equals to the negative n squared plus 47n plus 1. And with calculus, what we're going to do, we're going to take the derivative of the sequence to say it's going to be a negative 2n, it's going to be a 47, and the derivative of a constant is a 0, it's a 1 there. And we're going to argue to say at the maximum, remember at the maximum, that's where we get your stationary points. At the maximum, the first derivative should be equals to 0. Because at our turning points, the derivative is equals to 0. So that means I'm going to take this derivative and equate it to 0 because, we're looking at it at the maximum, at the stationary points. So this will be 2n plus 47 is equals to 0. And you can clearly see that n is going to be equals to 47 over 2, which we said is the same as 23.5. So I just took this to this side, it becomes negative, and I divide by the 2, and then it comes with the negative, and the negative will cancel each other out. I then get the same value of n as we did previously here when we use the turning point formula from algebra. And from here we can clearly see that our maximum will occur between T23 and T24. And that's how you would kill this problem. Stay tuned for question 3.